Number 1, the yearbook staff has designed a survey to learn about student opinions on how the yearbook could be improved for this year. If they want to distribute the survey to 100 students and obtain the most reliable data, they should survey who? Every third student who enters the band room, every third student who enters the library, every third student who enters the gym for a basketball game, or every third student arriving at school. So to get the most reliable data, when we do surveys, we want to get a representative sample. We want a representative sample. We want our sample to represent the population that we're asking the statistical question about. So if I just ask the kids in the band room, that's not representing everyone at the school. That's only representing the band nerds like I was going into the band room every day. So we don't want to ask just the band room kids because otherwise the whole yearbook will just be pages and pages of the band concert. So we don't want to do that. Every third student entering the library. Well, this seems like a good idea, but not everyone goes to the library. So you're not really getting a representative sample of the entire school because not every single student goes to the library. Number 3 is definitely not it, because just as if we don't want pages and pages of the band kids, we also don't want pages and pages of the basketball games. So every third student entering the basketball game, you're going to get a different group that doesn't represent the entire population. So every third student arriving at school in the morning is probably the best choice because everyone has to enter the school. So you're going to get a fairly representative sample of kids who are in the band room, kids who are in the library, kids who are at the basketball games. So we want our samples to be representative of the population that we're interested about. So we'll survey every third student arriving at school in the morning. Number 2, in the following, identify whether the subjects being described are the sample or the population. In some cases, they could be considered a sample or a population. Explain each answer. So some students in your class, and I want to know the number of books in their backpack. So if I'm asking some students in your class how many books they have in their backpack, those students in the class are probably just a sample. And we're probably wondering how many books do students carry on average? On average, how many books does a high school student carry? Or maybe it's a specific class, and you're only wondering about how many books do juniors carry? How many books do freshmen carry? You're not going to go around the building and ask every single junior or every single freshman, how many books do you carry? So by taking a sample there of just from students in the class, we're going to get a sample. So your explanation would be something about we're not asking everybody, we're just choosing a subset of that population. We would probably find the mean. We would probably use a sample mean here. So we would probably compute an x bar here to estimate mu, the that's the population mean. That's that parameter that we don't know. So we use our sample mean x bar to estimate mu. Moving on to the next one, AA batteries of a certain brand. So this clearly has to be a sample. This has to be a sample because you can't test every AA battery even if you wanted to. You could not sample, you could not study the entire population of this because there's a lot of AA batteries in the world. And we're going to measure their lifetime, so that's probably going to be a mean that we're going to look at again. We're going to find the average lifetime to estimate the parameter mu. We're going to use the sample mean to estimate the population mean. So it's clearly a sample because you're not checking every single AA battery that exists. If we were looking at the words in the US Constitution, and we're going to measure whether it's a noun or not. So there's a finite number of words in the Constitution, and it wouldn't be too hard to look through the entire document to find them. So chances are, if I'm looking at just the words in the U.S. Constitution, that's my population. That's my population that I'm looking at, and I'm going to look at the entire population. So I'm going to look at how many words there are. I'm not going to average them. I'm not going to say on average. I'm going to look at the proportion. So this is going to be a sample proportion, a p hat, and we're not even going to use a p hat actually because that's a sample mean. So we're actually just going to look at p. We're just going to look at p, the proportion of nouns. That's the population proportion p to estimate to see the true population parameter of nouns in the U.S. Constitution. We don't need a sample of that. You could take a sample of it, but we can just look at the entire population. We can quickly look at the U.S. Constitution to see and determine whether a word is a noun or not. Americans of voting age. There's a lot of them. There are a lot of Americans at voting age. So I hope that we're not the United States government doing a census every 10 years, because that's very, very, very expensive, a very, very expensive process to ask every single person of voting age. So this is definitely going to be a sample. This is definitely going to be a sample because you're not going to ask every single American how they feel. You're going to ask a sample that represents the entire population. So you're going to have to somehow get a sample that's representative of the entire US population. So you're going to ask them, do you agree with this issue, or do you favor this? Are you unfavorable about that? So that's going to be, we're going to get a p hat there. We're going to get a sample proportion to estimate the population parameter, the true proportion of Americans that feel about that issue P. So we use our sample P hats to estimate P. The big idea of this lesson today was to understand that we use our sample, we use data, we use statistics from a sample to estimate these population parameters, to estimate characteristics about that population that we don't know about. We're going to use inference. We're going to infer things about the population from that representative sample, which is why it's crucial that your observational studies and your surveys actually have representative samples so that we can make that inference to the entire population. And number 3, cops sat outside of Willow Avenue Elementary School because Willow Ave is clearly the best elementary school Cornwall Central School District has to offer, from 7 a.m. till 7 p.m. for 1 week. So the cops, they're just hanging outside of Willow, and they recorded that 1,235 cars drove by and 164 were speeding. Identify the statistical question the cops are answering, the sample, the population, and the conclusion the cops can draw about this population. So, this is definitely an observational study. This is definitely an observational study. Why? Because the cops are just sitting there and taking note of who's speeding or not. Maybe they're giving them tickets, we don't know, but they're just taking note of who's speeding or not. They're not asking it, they're not applying a treatment, nor are they asking people questions. So it's not an experiment nor a survey. They're just sitting there and recording who's speeding. So what statistical question do we think they were trying to answer? They're trying to answer what proportion of cars are speeding when they drive by Willow Ave. When they drive by Willow Ave Elementary School. That's a question, so there should be a question mark at the end of that. So, that's probably the question they were trying to answer. If they were just sitting there seeing who was speeding, they're probably wondering what proportion of cars are speeding when they drive by Willow Ave. What was their sample? Their sample was the sample was the 1,235 cars. That's their sample from that 1 week. And because they did it for a week from 7 a.m. to 7 p.m., this sample only represents the sample's data can only represent the population of cars that drive by Willow Ave from 7 a.m. to 7 p.m. We can't include the cars that drive. We don't know anything about the cars that drive at 8 p.m. Hope it's probably the same, but we can't infer that because our sample is only from that time period. So we can't use our sample for other populations that we didn't take our sample from. What was the population? The population is cars. Population is all cars driving by. And if we want to be really specific, from 7 a.m. until 7 p.m. That's if we want to be really, really, really specific. And we should be, because we're statisticians now. We're no longer mathematicians. We are now statisticians in this unit. What conclusion can the cops draw? Well, the cops have a sample proportion here. The cops have a p-hat. They have a p-hat of 164 out of those 1,235. So this is a part-to-whole comparison here. And what proportion of cars, what's our sample proportion for these cars here? Well, let's divide 164 out of 1235. When you type that into a calculator, you get approximately 0.133. So what conclusion can they make? Well, the best guess that they have, the best guess, or the best estimate for the true population proportion of cars that speed by Willow Ave Elementary School from 7 a.m. to 7 p.m. is approximately 13.3%. That's our best guess because that's what our sample proportion was. Our sample proportion is our best estimate, is the best estimate we have for this true population parameter. So, it's important that we understand the relationship between samples and populations and how we need our representative sample to represent our population so that we can use our statistic, use our p-hats or our x-bars to answer questions about the population parameters.